So in this video, we're going to focus on how we arrived at having the first principle formula. As you can see, what is easy to understand on how we can arrive to that is to simply draw a curve. So suppose we have a curve and we want to find how this curve is changing, or the rate of how the curve is changing. Suppose the name of this curve or the function is f of x. Suppose we have y being f of x, and we also assume that we have 2 points. Let's say we have the first point here, which has a correspondence value of x, and let's say we have another point. Now this point x, as we move this side, for example, as we move this side, we are definitely increasing by a certain quantity. So let's say we are increasing by the value of h. Let's say we are increasing by the value of h. So meaning our new x value this side is going to be x plus h. Our new value is going to be x plus h, meaning that point is going to be x plus h. That is on the x coordinate part. The same applies with this one. So we've only stated the x part. Now how can we get the y value part, or the other corresponding value? So all we need to do is use the formula of the given function, which is y equals f of x, and we must be able to fit. For us to get the y value this side, we should get this value as x and feed it into the value of x. Now that does not change, or meaning the y value is simply going to be the same as f of x. So meaning here the y value becomes f of x. Then the same is going to happen with this one over here, x plus h. If you want to find the y value using the same formula, again we have y which is equal to f of x. Now this x plus h, if we feed it into the place of x, it is going to be y equals f x plus h, x plus h. So meaning this new value here, this one is going to be x plus f of x plus h. Now suppose we want to find the gradient, because when finding the gradient we have to find 2 points on the curve. So meaning we need to draw a line. So we can draw a line of this particular curve. Then the next thing we're going to do is we need to, because we know that we need to find the coordinates of both points, because we know that for the formula of finding the gradient, it's simply m y2 minus y1 over x2 minus x1. Now here we know that this is x1 and we know that this is x2. We know that this is y1 and we know that that is y2. The next thing is we're going to now substitute in place of y2, which is f of x plus h, minus, in place of y, simply f of x, and then down on in place of x2 we have x plus h, minus, in place of x1 we have x. Now realize that this one and that one is going to cancel, because when you collect like terms, x minus x is going to be 0. So meaning you end up having fx plus h minus fx plus f of x or minus f of x. Now this is what you arrive at. Now you realize that this is changing, the one of the aim of calculus is to make sure that the space in here is small. So for example, as x is approaching this other point, this definitely will arrive at a point where it's 0. So meaning we can finally say as the limit when h approaches 0, because that's the limit, that's the lowest point, as the limit of x of h as h tends to 0, f of x plus h minus f of x is that, and that's how we arrive at the formula here. So I hope we've gotten the concept. Thank you.